Good afternoon, everyone. Today we're going to be learning about relating scale drawings to ratios and rates. So a drawing, I'm sure you know it would be a picture. And a scale drawing would be a picture that's either smaller, that's the same picture but smaller, or larger. As a do now, you should add these definitions to your vocabulary sheet. Dibujo a escala is a scale drawing. Reducción is a reduction. Ampliación is an enlargement, also known as a magnification. Correspondencia uno a uno, one-to-one correspondence. So a scale drawing is a reduced or enlarged two-dimensional drawing of an original two-dimensional drawing. A reduction happens when the lengths in the scale drawing are smaller than those in the actual object or picture. And an enlargement or a magnification is just the opposite of a reduction. That's where the lengths in the scale drawing are larger than those in the actual object or picture. And one-to-one correspondence. That's where each point in the figure corresponds to one and only one point in the second figure. Pause the video if you need more time to copy these terms. For the following problems, A is the actual picture, and B is the drawing. Is the drawing an enlargement or a reduction of the actual picture for each example? So for number 1, we started out with an actual picture, and then we switched to this right here. So your job is to write on this line either enlargement or reduction. Is that an enlargement to go from here to here? Or is that a reduction to go from here to here? Well, notice that the new picture is larger. So we actually got larger, it got bigger. So that would be an enlargement. In this second example, we start out with this picture, and then we have this other picture. Notice that the picture went from here to here, so it got smaller. So that would be a reduction. Pause the video if you need more time to copy this. Now you should be able to do this one on your own. For number 2, you're going to do the same thing. You're going to write either enlargement or reduction. So in this case, we start out with an actual picture, an original picture, and then we get to the scale drawing, and notice that it got bigger. That's an enlargement. It has the word large in it. Enlarge. It means we made it larger. It's large. And you should be able to do this one on your own too. If we start off with this original picture, and then we wind up having this picture here as the scale drawing, what happened to go from here to here? From the original to the actual, from A to B. What happened? Well, it got smaller. That's a reduction. We reduced the size. Reduction. Here's another example you should be able to do on your own. We start off with this image as the original, the actual picture, and then we're going to go to a scaled drawing over here. So to go from here to here, is it an enlargement or a reduction? In this case, it got bigger, therefore it's an enlargement. In this exploratory challenge, it says here we need to create scale drawings of your own on the grids provided. So there are some grids here, a small one and a large one, and we're going to create scale drawings of our own. We're going to copy the form twice, so copy the image twice. Okay, so we're going to put this rectangle on this coordinate grid by following how many boxes each point is away from the origin. So if this is the origin, to get to this point here, what I have to do is I have to go 1 to the right. So I'm going to do that over here, 1 to the right on that little one. It'll help to zoom in a little bit. So we're going 1 to the right. And then here it says we gotta go 1, 2, 3, 4 up. So we're gonna go 1, 2, 3, 4 up. So we have a point here. So now that I have showed you how to do the first point on this, all we're doing is copying the form, copying the shape on the smaller coordinate grid. Now that I've showed you how to do the first point, you can probably do the rest of the points. If you're still having trouble, you can keep watching the video and watch me do it. Okay, so chances are, if you're watching the video now, you probably already graphed your rectangle and want to see if you did it correctly. So let's see, we have 1 over and 1, 2 down. So we're going to do that over here. Zoom in a little bit. Go 1 over and then 1, 2 down. So we got a point here. And let's take a look at what we got here. We've got 1, 2, 3, 4, 5, 6, 7 to the left, and 1, 2, 3, 4 up. 7 to the left and 4 up. So let's see what we got. I'm going to copy this over here. Do the same exact thing, except it's smaller now. 1, 2, 3, 4, 5, 6, 7 to the left, and 1, 2, 3, 4 up. So we're right there for another point. And now let's count to get to this point. 1, 2, 3, 4, 5, 6, 7 to the left, and 1, 2 down. And you probably could have guessed this last point because it seems to line up with the other points in the rectangle. If not, if you couldn't guess it, then you could have gone 1, 2, 3, 4, 5, 6, 7 to the left, and 2 down, just like we did before. And now we're going to connect all the points of the rectangle, and we have a nice scaled drawing of the rectangle. So it's actually a reduction in this case because it's a smaller drawing of the original rectangle. So it is actually proportional. And by now I think you could probably make the enlargement of this rectangle on this coordinate grid. If not, you could watch me do this. So all you got to do is count from the origins. We got 1 to the right and 1, 2, 3, 4 up. So we got 1 to the right and 1, 2, 3, 4 up. So we got a point right here. And you continue in that manner, copying the points where they belong. 7 to the left, 1, 2, 3, 4, 5, 6, 7, and then how many up? 1, 2, 3, 4. So it lines up with that other point right there to make a nice side of the rectangle. That makes a side of the rectangle, and this lines up with this to make a point right here. And then we have another scaled drawing of the rectangle. So we started off with an original rectangle, and we had a smaller version in this coordinate grid and a larger version in this coordinate grid. So here was the reduction, and this was an enlargement. Okay, so now we're going to learn a little bit about a scale factor, and that's going to be a constant of proportionality or a unit rate or the K. There are a lot of different names for it, but they're all basically the same thing. So it means how much am I enlarging this shape or how much am I making it smaller. So in this case, we start out with this smaller shape and we're enlarging it to make an enlargement of the shape. So it says here, Luca drew and cut out a small right triangle for a mosaic piece he was creating for an art class. His mother really took a liking to the mosaic piece and asked if he could create a larger one, there's the larger one, for the living room. Luca made a second template, that's the second template, the larger one, for his triangle pieces. So now this is asking us here to fill in this chart. It says that we have height and width of the original image. Let's start with that. So let's figure out the height of the original image. The height of the original image. So here's the original image, and we're looking for the height. Well, from here to here, how tall is it? It's 1, 2, 3, 4, 5 boxes. So that's why we have a 5 and a 0. So 0 to 5 is 5 boxes. So the height is 5. And the width, I'm sure you can figure out by counting the boxes. So we have 1, 2, 3 boxes. Now pause the video and find the height and width of the second image. Okay, so what you should have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the width of the second image. And the height, how tall is it? As in your height, how tall are you? How tall is this triangle? Well, it's from here to here. And that should be 15. And if you really wanted to count the boxes, you could. You would count that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes, and you would get 15. In this case, we want to know if this is proportional, if a constant of proportionality exists. So let's see. If we have 5 times some number, some k, some constant of proportionality is going to give us 15. Well, what number times 5 gives us 15? That would be 3. And let's see if that's the same case for that was the height. Let's see if that's the same case for the width. The width. So we've got 3 times some number gives us 10. Well, it should be the same. If there is a constant of proportionality, it should be the same if this is an enlargement. So 3 times, it should be the same, 3 if it's proportional. Let's see if it's proportional. 3 times 3 is 10. Well, let's see. 3 times 3 is 9, which is not the same as 10. So